Binomial distribution or BINOMDIST. It returns the binomial probability mass function or the binomial cumulative distribution function. So the formula for the probability mass function is just this formula, which is combination of nx times p to the power x times 1 minus p to the power n minus x. So that's combination of nx times p to the power x times 1 minus p to the power n minus x. We'll generate these data sets using these values of x from 1 to 12. And this is for the x success rate in independent trials. Our n independent trials will be from 0 to 12. Data validation, that is from 0 to 12. And we save that. So our trials, we can choose from any value from 0 to 12. And the probability, we'll choose from three different values: 25%, 50%, and 75%. Data validation, and we choose the list of items. This will be the list separated by comma. Now we have three possible probabilities: 25%, 50%, and 75%. And we generate the binomial probability mass function, which is equal to array formula binomdist of the x values of n independent trials and at a p success rate 0, because this is probability mass function, and we choose, let's say we choose the total of 12 independent trials, and it's assigned 50% success rate. So this is the success rate of 50%. So the formula of the bell curve is combination times p to the x times 1 minus p to the n minus x. So we use this formula. Is equal to combination of n comma x times p to the x, p to the power x times 1 minus p to the power that's to the power n minus x, n minus x. And we lock the references of p and n. So starting with combination, then the power, that is p to the x, and 1 minus p to the x. So 1 minus p, we log p to the power x minus n, or n minus x. Enter. These values match because this is the alternative formula for the binomdist probability mass function. As we drag this downwards, that's the shaded area under the bell curve. We can use this, we can measure this area using the length times width. The width is 1 because the, the difference between each is 1. So that we have 1 unit for the width for each. And the length will be this. So that's length times width. So we drag this downwards. So that covers the area under the bell curve, the shaded area under the bell curve. The shaded area under the bell curve can be calculated using the BINOMDIST or the cumulative binomial distribution, which is equal to array formula. BINOMDIST of the x values for n trials at a success rate of 50%, and 1, the last argument, because this is a binomial cumulative distribution function. So the value approaches 1. And we can use alternative. It's an area because B, the cumulative, is the summation of this. So this is equal to, if this is 0 or empty, then it's empty. Otherwise, we use sum of this range, the summation. And we lock the reference. So this cell measures the area under the bell curve. So enter this. So at this range, this matches to our binomial cumulative distribution function. We drag this farther upwards and we drag this downwards. You'll notice the green line measures the area under the bell curve. So we go farther and that completes, also approaches 1. If I delete a portion of the bell curve, I will have three columns shaded area. And the total area of that is 1 times this area plus 1 times this area times 1 times this area. So this will be 0.01928, which matches to our binomial cumulative distribution function. If I drag this further, halfway through, so I have a total area of 0.61279, which matches to our binomial cumulative distribution function, and the probability mass functions also match. If I drag this further, the area under the bell curve measures 0.98017. This is the red area under the bell curve, which is measured by this. Further, this is 0.029. The value decreases because that's the height, but the total area accumulates to 0.999. And as I drag this farther down, it approaches 1. Just like any other cumulative distribution function, the area approaches 1. I can change the value of the trials to a lower value, which says 7. So I'll be measuring up to a maximum of 7 independent trials at a 50% success rate. So for up to maximum of 7 trials, at, for example, three attempts, I will have 0.27 or 27 success rate. Assuming at 50%, I will have a total accumulation of 50%, and the success rate will be at 50%. The probability is 0.27. So I increase that to 75. This will be the bell curve. If I increase this to 10, if I lower this to 25, so the cumulative distribution function measures the area under the bell curve, where it is also known as the probability mass function. This completes the binomial distribution in the cumulative distribution function and the probability mass function.